I stretch this slinky. A longitudinal wave is like this, and a transverse wave is like this. So perpendicular, parallel to the oscillation direction, longitudinal parallel, transverse perpendicular to the propagation direction. The slinky was the simple do-it-at-home version of longitudinal and transverse waves. I have more high-tech ways of demonstrating precisely the same concept with a hanging slinky here that I can activate by giving a quick pulse to one end of it and then watching the wave propagate through the slinky. This is a longitudinal wave, compressions and rarefactions of the slinky coils, and symbolizing what happens for sound in ear. And you watch these beautiful compressions going from your left to your right. Let me do it again. I never have enough of this. This is so much fun. And beautifully going from your left to your right. Compressions and rarefactions. This is a longitudinal wave, same direction, propagation and vibration or oscillation of each coil on the slinky, or pressure or particles in air. Here instead, I have a transverse wave. There's a series of bars. Follow the tip towards you for each one of these bars. I'm going to give it a jolt in one direction, which is a pulse, and then I'm going to watch that wave propagate from your left to your right. Let's watch it. It's just one pulse, and it gets to the other side and gets reflected and comes back, and something more complicated happens. But let's just worry about the propagation and the oscillation direction. The oscillation direction is obviously up and down for each point at the end of this bar. And if I go continuously, you can see a beautiful wave propagating from your left to your right. Transverse wave, perpendicular, oscillation of each one of these metal bars, whereas the propagation direction of this wave, this disturbance traveling in space, is actually from your left to your right. So, perpendicular, parallel, transverse, longitudinal. Thank you.